Have you ever looked up at the night sky, filled with countless stars, and wondered, how will this all end? It's a question that has captivated humanity for centuries. We think of the universe as eternal, but just like everything else, it has a beginning, a middle, and an end. So, grab your cosmic popcorn, because today, we're re-embarking on an epic journey to the very edge of time to explore the ultimate fate of our universe. First, let's set the stage. Our universe began about 13.8 billion years ago with the Big Bang. Since then, it's been expanding, and this expansion is the key to understanding its final chapter. The fate of the universe hinges on a cosmic tug-of-war between two opposing forces. Gravity, which tries to pull everything back together, and dark energy, a mysterious force that's pushing everything apart and accelerating the expansion. The winner of this battle will determine how the final scene plays out. Currently, our best observations suggest that dark energy has the upper hand. This leads us to the most widely accepted theory for the end of the universe: the heat death, also known as the Big Freeze. It sounds a bit grim, but it's actually a slow, gradual process. So, what does it look like? Let's fast forward about 100 billion years from now. The accelerating expansion of the universe will have pushed all galaxies, except those in our local group, so far away that their light can no longer reach us. The night sky will become a dark, empty void. Imagine looking up and seeing only the stars of our own merged galaxy, the Milkomeda galaxy, with nothing but blackness beyond. It would be a lonely existence. Now, let's jump even further ahead, to trillions of years in the future. Star formation will have ceased long ago. The universe's supply of gas, the building blocks of stars, will be exhausted. The last of the small, long-lived red dwarf stars will finally flicker and die, plunging the cosmos into an era of darkness. The universe will be populated only by the remnants of stars, white dwarfs, neutron stars, and black holes. Even these stellar corpses won't last forever. Over unimaginable timescales, we're talking quadrillions of years. Planets will be flung from their orbits, and the remaining stellar remnants will be ejected from their galaxies. The galaxies themselves will dissolve as everything drifts apart into the cold, dark void. But the story doesn't end there. We entered the black hole era for an incomprehensibly long time. Black holes will be the last remaining organized structures in the universe. They'll slowly swallow any stray matter that comes too close. But even black holes are not eternal. Thanks to a process called Hawking radiation, they slowly evaporate, losing mass over eons. A solar mass black hole would take around 10 to the power of 67 years to evaporate. The supermassive black holes at the centers of galaxies, they could last for 10 to the power of 100 years, a number so large it is difficult to even write down. Once the last black hole has evaporated in a final, faint pop of particles, what's left? This is the true heat death of the universe. The cosmos will be a vast, cold, and nearly empty soup of elementary particles. Photons, neutrinos, electrons, and positrons drifting aimlessly in an ever-expanding darkness. All activity will cease. The universe will reach a state of maximum entropy, where energy is perfectly distributed, and there's no more potential for work or change. Time itself might lose its meaning. It's the ultimate state of equilibrium, a silent, eternal, and unchanging void. Now, this Big Freeze scenario is the fruitrunner, but scientists have considered other, more dramatic possibilities. One is the Big Rip. In this scenario, dark energy is even more powerful than we think, a form called phantom energy that grows stronger over time. If this were the case, the expansion would accelerate so violently that it would eventually overcome all other forces. First, it would tear apart galaxies. Then, it would rip apart star systems, separating planets from their stars. In the final moments, the fabric of space-time itself would be torn apart. Stars, planets, and even the atoms that make up our bodies would be shredded into their fundamental components. It would be a very quick and violent end. Another possibility is the Big Crunch. This would happen if gravity, perhaps aided by a change in the nature of dark energy, eventually wins the cosmic tug-of-war. The expansion of the universe would slow down, stop, and then reverse. Galaxies would start rushing toward each other. The universe would get hotter and denser as it collapsed back in on itself, ending in a fiery singularity, much like the one that started it all. Some theories even suggest this could lead to a big bounce, where the universe is reborn in a new Big Bang, creating a cyclical cosmos that expands and contracts for eternity. So, which one is it? A cold, quiet fade into darkness, a violent rip, or a fiery rebirth? Right now, the evidence points toward the big freeze. But the truth is, we're still learning. The nature of dark energy is one of the biggest mysteries in modern physics. Future discoveries could completely change our understanding of the universe's ultimate destiny. It's mind-boggling to think about these timescales and cosmic events, but it also gives us a profound sense of perspective. Our lives, and even the entire history of humanity, are just a fleeting moment in the grand cosmic story. It makes you appreciate the here and now, this vibrant, dynamic, star-filled era of the universe that we are so incredibly lucky to be a part of. The universe is alive with possibilities, and we get to be here to witness it. What do you think will happen at the end of the universe? Let me know your thoughts in the comments below. And if you enjoyed this journey to the end of time, don't forget to like this video and subscribe for more cosmic adventures. Thanks for watching, and keep looking up.